Hey guys, how are you? Welcome back to the channel. Today is day 14 of upskilling myself, and today I solved 3 DSA problems. And I had some internship work as well as I had been assigned the front end task for my internship. So I went through the code base, and yeah, that took most of my time. So let's go to DSA problems. So the first problem that I solved was number of good pairs. So it's an easy little problem, and what we have to do over here is we have been given an array of integers and we have to return the number of good pairs. What is a good pair? Over here, if you see this and this, these three form a good pair, like 1 and 1 at the 0th index and the 3rd index. You see over here, a good pair is a pair whose nums of I is equals to nums of j. That means these two are equal and their indices are in the incremental format. So this is the 0th index, this is the 3rd index, and 3 is greater than 0. So this is called a good pair. So to solve it, we are using a hash map. So let's see the code. So we are creating a hash map, which is frequency map, which maps number and its frequency, right? And we have to add this frequency in the count on every iteration. Okay, so we are initializing count as 0 and we are we are traversing through the vector, and then if we find that particular num in the hash map, then we will add the frequency into the count, and then we'll increment the num into the frequency hash map. Okay, so the second problem is continuous average sum, and we have been given an integer array nums and an integer k. Over here it's 6, and we have to return true if the nums has a good subarray or false if it doesn't. A good subarray is a subarray where the length is at least 2, that means it has elements more than 2, and the sum of the elements of the subarray are a multiple of k. So over if you see, 2 and 4 forms a subarray, right? Because it is at least 2 and the sum is a multiple of 6, right? So to solve this, we are using prefix sum as well as unordered map. Okay, so first of all, we are initializing the size, then we are creating a hash map which stores mod and the index mod just for the multiple, and then we initialize 0 as -1 because we want to eliminate any negative numbers or zeros. Then we initialize the prefix sum variable as 0, then we traverse to the array. We after every iteration we add the nums into the prefix sum and we mod the sum, and then we find the mod into our hash map. If it's available in the hash map and the difference is more than 1, then we return true, else we add the mod into the hash map. After all this, if we don't get any subarrays, then we return false. The third problem was contiguous array, and we have been given a binary array of nums and we have to return the maximum length of a contiguous subarray with an equal number of zeros and ones. So let's take an example of 0, 1, 1, 1, 0, 0, 0, and 1. So over here, this would be the contiguous subarray because it has equal number of ones and equal number of zeros, right? So to solve this, we can use either prefix sum or we can also use sliding window, but prefix sum is a preferred one. So let's see. So what we can do is we can set all zeros as -1, and then we can just go to prefix sum, and if we find sum is equals to 0, sum is equals to 0, that means -1 and 1 cancel out each other and we get equal numbers of zeros and 1. Then we store the sum into our hash map. First of all, we have to set all the zeros as -1, then we will create a hash map to store the sum, and if the sum is already in the hash map, then we calculate the length and we compare it with the answer. If the length is greater, then we set it as answer, else the answer remains the same. So we create a map, then we map 0 with -1 to avoid negative numbers, then we get the size, then we create two variables, prefix sum and the result length, which is the maximum length. Then we traverse to the array, we calculate prefix sum. If prefix sum is 0, if the element is 0, then we add -1, else we add 1. Okay, if we get the sum into the hash map, then we calculate the length and calculate the max length and store it into the result length, else we add that sum into the hash map. After all, we return the maximum length. Okay, so for the development part, I did internship work and I was assigned the front end task. So I went to the code base, I understood the code base, and yeah, it took most of my time. Then I did YouTube stuff and revised all the DSA problems that I did till now. So thank you guys for watching and see you on day 15.